We mentioned the higher level protocols that run over the Internet Protocol, IP. Well, there are two of them that we're going to be talking about. The first is TCP, or Transmission Control Protocol, and the second is UDP, or Universal Datagram Protocol. TCP over IP is the one you're most likely to have heard about. It's the most popular complement to the Internet Protocol. It's a connection-oriented protocol, which means that the first thing you do when you're running this protocol is establish a connection between the two devices that are communicating with each other. This initial setting up of a connection is called a handshake. The handshake is completed with just a few packets being exchanged. Once established, this connection tells the sender of the data to put a little more information into the packet headers so that it's easier for the receiver to tell whether something is going wrong during the transmission. Like, are the packets coming out of order, or is there packet loss or duplication? It also makes it easier for the receiver to notify the sender that there's a problem. When this happens, the sender can take some kind of action. For example, the sender might need to resend some packets, or the sender might decide to slow down the transmission speed, so the packets are less likely to be dropped or arrive out of order. Of the two main transport layer protocols we're going to look at, TCP and UDP, TCP is definitely the one that favors reliability over speed. TCP is going to make sure that you get your documents, your downloads, your pictures, your web pages. TCP is going to make sure that all of these arrive intact. TCP provides reliable, ordered, and error-checked delivery of your packets. And keep in mind that just because it favors reliability over speed, that doesn't mean it's slow. TCP is fast, it's just not quite as fast as UDP. Its combination of speed and reliability is the reason that TCP is the most common internet protocol that's paired with IP. UDP, or Universal Datagram Protocol, is a connectionless protocol. It does not require the handshake that TCP does. In fact, a sender can send information to a particular address on the network using the UDP protocol and not even be certain if the machine or device at that address is turned on. Those packets will just keep streaming, and eventually they'll be dropped by a router that can't find the address. Now, typically, a sender isn't going to send out information unless a request is made. But even if the receiver is online and listening, it has no guarantee that the packets are going to arrive in order, or that the packets won't be dropped or duplicated. Those things are guaranteed with TCP at the network level. A packet that does not come with any such guarantees is usually called a datagram. If you do need some guarantees with UDP, you could always build them into the application you're using. But, that could potentially slow things down and defeat the purpose for using UDP in the first place, which is speed. UDP is great for things like streaming live multimedia, like audio and video, especially when it's more important to get the media stream fast than it is to get the media stream perfect. Now, what does that mean? Suppose I'm doing some kind of live video chat with someone on the other side of the world. Well, I want as little lag as possible, so I'm going to use UDP. But what about packet loss? Well, packet loss is going to affect the quality of the audio or the video. And if a couple of packets are dropped every so often, it's not really going to affect the quality of the conversation. And if it does, I can just ask my friend to repeat what they said. Furthermore, packet loss is almost always due to network congestion. If the network traffic between us is not that congested, I may not even encounter packet loss. Okay, one more thing about UDP. If I'm just sending and receiving one packet of information, and remember, that's about 1 page of a text file, I don't need to worry about things like packets getting out of order. So UDP is often used for small queries like pinging a server to see if it's awake, or requesting the IP address, which is a number like 8.8.4.4 that corresponds to a particular domain name, which is a string like dns.google.com. Here's a table that gives a couple distinctions between TCP and UDP. We've talked about most of these already. TCP is connection-oriented. It requires a handshake before computers can exchange significant amounts of data. UDP is connectionless and does not require any handshake. TCP guarantees that the data will arrive in order and that no packets will be lost. UDP has no such guarantee. If the packets don't reach you, they don't reach you. TCP is slower than UDP, and UDP is faster. TCP is considered heavyweight because each packet contains more overhead, while UDP is considered lightweight. TCP is useful for documents, web pages, transactions, text, and binary applications. UDP is useful for live media and small queries. Finally, TCP is the most popular protocol on the internet, though UDP is continuing to grow in popularity as the network itself becomes more reliable. Okay, we've seen the differences between these two protocols. Now let's try to match some real-world internet applications to the protocols they might use. For example, Google, Amazon, Skype. What protocols do you think these services use? In the next slide, I'm going to show you a list of real-world internet applications. When that slide comes up, please pause the video, and for each one of those applications you see, decide whether it uses TCP or UDP. Don't just wait to hear my answers. Pause the video and think about it. Okay, here it is. Ready? Okay, we've got a lot of applications here. We've got Amazon, Dropbox, DNS Lookup, Facebook, Gmail, Voice over IP, World of Warcraft, and Netflix. So let's examine them one by one. First, there's Amazon. For this one, I hope you said TCP. TCP is all about reliability. You don't want to send $50 to Amazon and have them tell you they never got it. What about Dropbox? TCP, of course. I'm transferring important documents to the cloud. I'm trusting Dropbox will maintain those documents intact. What about DNS Lookup? Well, actually, we've already said this one. This is when you have a domain name and you want to find its IP address. This is UDP. The request for this can be made using a single packet of information. If it doesn't look like there's any response after a second or two, no big deal. Our web browser can just send the request again. Okay, what about Facebook? Facebook has got to be TCP. Can you imagine what would happen if the funny picture of our cat was corrupted when we tried to upload it? All our friends would laugh at us and we probably wouldn't get any likes, okay, which would be terrible. Okay, so Gmail is TCP. We don't want any problems with our email. What about voice over IP? I think we might have mentioned that this one is UDP. If the audio quality suffers a bit due to packet loss, it's usually not a big deal. At least we don't have that awkward 1/2 second delay when we're talking to someone. Okay, World of Warcraft is a massively multiplayer online role-playing game. There's a lot of multimedia involved, audio and video, and it's real time. And that's why it's UDP. If you get some packet loss, you might drop a frame of video every once in a while, but it's generally not an issue. Now, there are functions in this game where you can do things like send a text to someone that you're playing with. You want that text to arrive intact, so the text will be sent using TCP. That should tell you that for sophisticated applications, there's no reason to limit yourself to just one protocol. Okay, finally, I saved Netflix for last. Now, as of 2015, Netflix accounts for more than 1/3 of peak download internet traffic in North America. That's double of YouTube and way ahead of iTunes. So we're talking about streaming video here. What protocol do you think it uses? The answer is, as far as I know, TCP. But I would say there are good arguments for using both here, and it's possible that they use a combination of the two. If anyone can find what they think is a definitive answer to this one, please let me know. I'm interested. And provide a reference, because I would love to be 100% sure about this. And that's it for this video on Internet protocols. In the next video, we'll talk about the OSI reference model and see what other protocols are used at every layer of an Internet application.